This is 1.6, solving polynomial equations. So we've solved equations before with factoring, the square root method, quadratic formula, completing the square. So we've used different methods, so we're going to kind of combine it together with these a little bit more difficult problems. So a problem like this, how to solve this, you might be tempted, I just want to remind you, you might be tempted to divide both sides by x squared. You could never divide by x squared, by the way, or x, because x could be 0, and you could never divide by 0. So, make sure that you don't divide both sides by an x. So in this case, you want to bring everything over to one side. And then we're going to factor out the common the GCF, so 3x squared. Then notice this can factor even more. And then you set each of these equal to 0, which that's going to give you an answer of 0. This is going to give you an answer of -4, and this is going to give you an answer of 4. Just an additional comment, you should always check your answers. Sometimes, even though mathematically we came up with 3 answers, sometimes when you plug them back in and check them, sometimes they don't work. So you should always check your answers. In this case, all 3 of them do work. All right, so let's look at this expression. We've done problems like this before, and hopefully as soon as you see this problem, you see that there's 4 terms, and then you want to factor by grouping. So if you look at the first 2, what's common with the first 2 is x squared. And look at the second 2, what's common is a 3. And then notice these 2 will match. So x minus 3. And then x squared plus 3 remains. Then you're going to set this equal to 0. And notice this one, when we set this one equal to 0, and then you take the square root of both sides, we're going to get plus or minus the square root of 3i. And again, you want to check your answers. So there's actually 3 answers here. And you can always check your answers. And also be careful, and sometimes it might say solve for any real numbers. In this case, if it did say that, if it said that, then these would not work. Okay, then they would not work. But because here it just says to solve. All right, so this one right here, if you look at this one, you're like, well, there's no 4 terms, there's no GCF, what do I do? Well, what we're going to actually do, because what if that was x squared minus 3x plus 2? Like, what if? Then this would be an easy factor, right? X minus 2, x minus 1. See, that would be an easy factor. So on this one, what we're going to do is we're going to do a little substitution. So let me start all over. So what we're going to basically do is and I'm just going to pick a variable, but let's let w equal x squared. Okay, so I'm just creating a number w, a letter w, and so every w is x squared, or x squared is every w. So this is actually going to be w squared minus 3w plus 2. And then if we factor this, it's w minus 2, w minus 1. And the reason why we do that is to help us get to that step so we can factor it. And once we get to that factoring step, then we substitute it back in. Because remember, w is actually x squared. And then what we do is now set this equal to 0. Set this equal to 0. Take the square root of both sides. And notice we have 4 answers. And again, notice something you should pay attention. There's the exponent's 4, and we have 4 answers to be able to solve those. So let's go back to this one right here. So our next example is, typically when you see a square root equation, you want to square both sides and to get rid of it. So we can't square. Whenever you square, even if I had something like square root of x equals whatever, 5. you want to isolate the square root, okay? To isolate it, then you square both sides. Well, this is not isolated yet. So first we need to isolate the square root. Get the square root all by itself, and then you're going to square root both sides. So now if we square both sides. So if we square this side, we also have to square that side. And so this is going to become 2x plus 7. And make sure you're going to FOIL this. That's what the squared means. So you actually FOIL it. And then you're going to solve this equation. So here we're going to get 2x minus 3. Bring everything over to one side. Factor. Set them equal to 0. Now, I've said this almost in every problem, but make sure you go back and check your answers, especially with square roots, because sometimes they won't work, okay, if you actually plug them in. All right, and when you check this, you'll see that -3 does not work, so only 1 is the answer. And I want to be clear on this, just because it's negative doesn't mean it doesn't work, okay? You could still have a negative answer, but you need to check them both to make sure that it actually works. So again, especially with square roots, make sure you check them. All right, so on this problem right here, so this one's, you have square roots like this, and what you want to do is isolate the square root if all possible, and then we're going to square both sides, very similar to the last problem. So we're going to isolate one of those. So I'm just going to take the other one over. And then I'm going to square both sides. Now be careful again, when you square this side, you're going to literally FOIL that, okay? So this is literally the square root of x minus 3 plus 1, and then the square root of x minus 3 plus 1. This side over here works out nice. So when you start to FOIL this, so square root of x minus 3 times square root of x minus 3 is just x minus 3. Again, just like the square root of 2 times the square root of 2 is 2. The square root of 3 times the square root of 3 is 3. So the square root of x minus 3 times the square root of x minus 3 is just x minus 3. And then you have 1 square root of x minus 3, and then the same thing here. And then 1 times 1. I'm going to combine like terms together. So let's see, x is 2. 1 plus 1 is 2 square root of x minus 3 minus 2. Because I combine those two together right there. All right. So this right here is still 2x minus 5, 2x minus 5. And again, just because we have a square root in the problem, we want to isolate the square root. So I really want this to be by itself. Okay, so I'm bringing the x over to the left side, and then bringing x and numbers over to one side. Now, once I get down to this step, to get rid of a square, you square root. So I'm going to literally square this side, and I'm going to square this side. So here, if I FOIL that, I'm going to get x squared minus 6x plus 9. If I square this, I'm going to get 4. Again, 2 times x minus 3, and then 2 square root of x minus 3. I'm going to get 4 when I multiply 2 times 2, and then square root of x times square root of x minus 3 times the square root of x minus 3 is just x minus 3. Then we're going to use the distributive property and get everything over to one side. So again, I'm using the distributive property and then get everything over to one side. I'm going to get x squared minus 10x plus 21. Factor that, it goes to x minus 3, x minus 7. And then set those equal to 0, and you get 3, and you get 7 as your two possible answers. I say possible because, again, anytime you have a square root, you need to go back and check it and make sure it actually works. So both of these actually do work. So both of those are your answer. You might want to pause this and go through that step again and again, because we had to actually square the problem twice to get rid of the square roots. So, and you just had to get used to the strategy. So, again, I suggest you look at that problem a little bit more detailed and make sure you understand how to solve it. All right, so this problem, we've actually done this problem before, and there's two ways to do this problem. So I would suggest that when you get to this problem that you consider both ways and which way you feel more comfortable with. So notice this is to the 2/3 power. So what we're trying to get down to is x. So we need to get rid of 2 to the 2/3 power. Well, one way to do this is we're going to cube both sides. One way to do that is to cube it. Just because then it will cross out the denominator there, and then you would be left with x minus 4 and then 25 squared. So you could do it that way, and then add 4 to both sides. This is x minus 4 squared. Then you could, I'm showing you this as a possible way to do it. So you could do it that way. Or another way to do this is just to literally think of this as like x minus 4 squared the cube root. And I've said this to you before, the denominator is the root. The denominator is the root. So because that's a denominator of 3, that's a cube root. Now the reason why this is a good method to do it is because now to get rid of a cube root, we're going to cube up both sides. It's very similar to what we did last time. So either way is fine, but you want to cube up both sides. So this is going to be x minus 4 squared equals 15,625. And I'm actually going to, because we've already talked about that, that's x minus 4 squared, so I'm going to multiply that out. You know what? That is possible. Then we could solve it that way. Let me back it up because I think it's easier if we. I was about ready to do it that way and then set it equal to 0. But I think it's easier to just square root both sides to get rid of that square. I think it's easier to do it that way. So this is going to be x minus 4 equals plus or minus 125. Yeah, this works out a lot easier. And then x equals 4 plus 125 and 4 minus 125. So 129 and negative 121. And that's the solutions to both of those. And then one last problem involving fractions. We've done similar problems to this. What we're going to do is find the common denominator, which is x minus 2, and basically multiply everything by x minus 2. So, and the reason why we do that is to get rid of the fraction. So notice the x's cross out, and so you have 2 times all of this. Here, the x minus 2's cross out, and you have 3x. And then here we have a negative x distributing, so negative x squared plus 2x. And then from there, it's kind of easy to solve. So 2x minus 4. Let me combine my x's together. So negative x squared plus 5x. And then I'm going to bring everything over to one side. Back to that. And then set this equal to 0, and you get 4. Set this equal to 0, and you get negative 1. And then always check your answers. I want to keep emphasizing that. Make sure you check your answers, especially with square roots and anytime that you have a denominator. So with an x. So you always want to check it. For instance, like you guys see that this, like here we could see at the very beginning, x cannot equal 0. And at the very beginning, x cannot equal 2 because you can't have 0 on the bottom. So because it can't equal 0 and 2, if we would have came up with one of those answers, it would not have equaled that. So here we came up with 4 and negative 1. If you go back and check both of those answers, they do work. So that's how you solve problems involving fractions.